Hi, welcome to the channel. Here I post challenging math video problem daily. If you like this video, then give it a thumbs up and subscribe to the channel. So without further delay, let's start. Today we have two problems based on graph. First problem said find all pairs xy belongs to real, satisfying this equation sin x plus y by 2 equal to 0 and mod x plus mod y equal to 1. So what we can do is solve this two equation and plot the graph, and the intersecting points between these two equations are the solution to these uh, equations. So for the first part, sine x plus y over 2 is 0. So 0 means we can write sine 0 as 0, then sine pi equal to 0, then sine 2 pi, 3 pi. Similarly for minus pi, minus 2 pi. So we can simply write sine n pi, where n belongs to z, all values. So x plus y by 2 equal to n pi. So x plus y equal to 2 n pi, where n equal to 0, plus minus 1, plus minus 2, and so on. Okay. Now we have our first, for the first equation, we have x plus y equal to 0. If we put n equal to 0, then x plus y equal to pi. We take both plus minus, so we can write plus minus pi, then not plus minus pi, plus minus 2 pi. Okay, then x plus y equal to plus minus 4 pi, and so on. Okay, now for this second equation, we have mod x plus mod y equal to 1. So if we open this mod, so we have x plus y equal to 1, where x greater than 0 and y greater than 0. Similarly, x, if we open x less than 0 and y greater than 0, we have x minus x plus y equal to 1. Similarly, x minus y equal to 1, and the last is x plus y equal to minus 1, when both x and y both are 0, both are less than 0. So if we plot this equation, okay, so say for the first equation we have x plus y equal to 0. So x plus y equal to 0 means this graph passing through origin and with a slope of -1. Okay, now x plus y equal to plus minus 2 pi. So 2 pi means approximately 6.12. So 6.12 means, say this is 1. So 2, 3, 4, 5, 6. Here it is somewhere. Okay. So we just draw. So what we have is this line parallel, and it cuts like this. Okay. So this is x plus y equal to 2 pi, and this is x plus y equal to minus 2 pi. And similarly, all other lines we can easily draw. So this is the graph of this first equation. Now the second equation is, if we plot, so x plus y equal to 1. So this is, then if we plot this equation, we have a square. Okay, so this is 1 comma 0, this is 0 comma 1, this is minus 1 comma 0, and 0 comma minus 1. Okay, this green graph is x equal to minus y, and this all other equations are minus x plus y equal to 1, x minus y equal to 1, and last is x plus y equal to minus 1. Okay, no, just wait a minute. This is x plus y equal to minus 1, and this is x minus 1 equal to. Okay, so what we have here, if both the graph we have drawn and this is the intersecting point, this is the first intersecting point and this is the second intersecting point, so the value of these points are minus half comma half, and similarly this point is half comma minus half. So our ordered pair which satisfy both the equation are minus half comma half and half comma minus half. So this is the solution of the first problem. Now for the second problem, we have the problem says that consider the function fx equal to sine pi by 4 x minus box function of x, greatest integer function, and when box function is odd, and second is when cos pi by 4 1 minus x plus box x when box x is even. So what we have to find is we have to draw the graph of this function and determine the discontinuous points and the non-differentiable points of this function. So let me write this function fx equal to sine pi by 4. Now x minus box x can be written as sine pi by 4 and fraction part of x. Okay, and this is when box function is odd. Okay, and all the values of x is greater than 0. Similarly, for the second part, cos of pi by 4 1 minus, if we take negative as common, so we can write this as cos pi by 4 1 minus fraction part. Okay, when box is even. Okay, now just to remind you, if we plot the fraction part x, we are plotting only for x greater than 0. So this is 0 1 2 3 4. Okay, so in between 0 and 1 our fraction part is this line, so this is y equal to x line. Okay, for the point between 1 and 2 the fraction part be this, so this is y equal to x minus 1. For in between the line y equal to between the line x lies between 2 and 3, y equal to x minus 2, and so on. Okay, now we will further simplify this equation function. Okay, so let when x lies between, okay, so what we are right here, just a minute, when x lies between 0 and 1, box x value is 0, and our, so box x is 0 means the function is even. So the function is even, then function is cos pi by 4 into 1 minus, wait a minute, 1 minus x. Okay, because in between 0 and 1, fraction part of x is x. Okay, so this is first. Then if x lies between 1 and 2, okay, so we can write is this is even odd function, then that's why we have used this cos function. If x lies between 1 and 2, so box function is 1. Okay, so 1 means if this is even, this is odd, so odd we have to use the sine function, sine pi by 4, then x means x minus 1, fraction part. Okay, similarly in between x 2 and 3, box function is 2, so 2 means again even. Okay, so we have to use cos function, so cos pi minus 4, then in between 2 and 3, our fraction part equation is 1 minus x minus 2. So 1 minus x minus 2 means cos pi by 4. So if we open this, so we have 3 minus x. Okay, in between 3 and 4, box function is 3, so 3 means we have odd function, so odd function means we have to use sine. Okay, so sine pi by 4, then fraction part of x, fraction part of x means x minus 3. So you can easily see that it will be continued like this, say 1 minus x, then x minus 1. In between 2 and 3, it is 3 minus x, then x minus 3. So the next is, say we will write two more, say 4 to 5. 4 to 5 means box function is 4, 4 means even. Okay, so we will use cos function, so cos pi minus 4, then 1 minus, say in between 4 and 5, the function is x minus uh, this is x minus 4. Okay, so for the function should be like cos pi by 4, then 4 minus 1 means 5, 5 minus x. Okay, so similarly in between 5 and 6, box function is 5, so 5 means odd, so sine pi by 4, then x minus 5. Okay, so we have already figured out the function. Now it's time to plot it. Okay, so this is 0. Okay, now in between 0 and 1, okay, so this is say 1, this is 2, then 3, then 4, then 5, and so on. Okay, now what we have is if we plot between 0 and 1, we have cos pi by 4 into 1 minus x, this first function, this function, this function. Okay, so what we have is putting x equal to 0, we have cos pi by 4. So cos pi by 4 means 1 by root 2. So this is say 1 by root 2. Okay. So the function will start from here. Okay. The function will start from here. Then 0 to 1. 1 means if we put x as 1, so we have cos 0. Cos 0 means 1. So we have this is 1 point. Okay. Wait a minute. This is 1 point. Okay. So our graph, this is 1. So cos function will increase as soon as it reaches to 1. From next is from the point between x1 and 2. So 1 and 2 means sine function. So sine function, if we put x as 1, okay, so it will never reach it. So we can make a hollow circle here. So sine function means sine, if we put x equal to 1, so we have 0. Sine 0 means this 0. Okay. So this is the sine function. Then if we put x as 2, so we have 2 minus 1 means sine pi by 4. So sine pi by 4 means 1 by root 2. So this is sine pi by 4. So this is sine pi by 4. Okay. It will increase. Then in between 2 and 3 is if we put x as 2, so we have again cos pi by 4 means it will start from here only. So we will write this value, and then if we put x as 3, so we have again cos 0 means 1. So again it will go like this. It will continue, this graph will continue, and this line, so suppose this is the dotted line, so this is 1. Okay. And this green is for cos function, this is cos function, and this blue is for sine function. Okay. So again at point between 3 and 4, so 3 and 4, if we put x as 3, so sine 0, so again it will come back to here and it will again plot. So similarly, and between 4 and 5, again cos function, so 4 is again cos pi by 4, it will start from here. Okay. So just wait a minute, and it will continue to 1. So this is okay. So this is the graph, it will follow. Okay. Okay. So this is a curve. Okay. Cos function, this is basically a cos function. So if we it is understandable, I think. Okay. So this will continue. Okay. Now second portion is we have to find the point of discontinuity. So see, discontinuous point and non-differentiable point. So discontinuous point is this 1 point is discontinuous. Okay. Then again 3 point is discontinuous. Again 5 point is discontinuous, which means that every odd integer points are discontinuous points. So point of discontinuity is 2n minus 1, where n belongs to integer. Okay, and DJ plus we can write. Okay, and similarly point of non-differentiable point, non-differentiability is same, because for all the point of discontinuity, that the same point, the function is also non-differentiable, because all the other points the function is differentiable. If we check here, it is completely continuous slope. Okay, so our answer is also the same, 2n minus 1. So these are the points of discontinuity and point of non-differentiability. Okay, so I think it is fairly a good question. It is a very good question. And the first problem has already came in, I think ISI exam in 2018. It has come. And the second problem may come in any JE problem, JE examination. So it is that kind of a question. Okay. So this is all for today. See you tomorrow.